All right, let's make a start. So today we are looking at balancing chemical equations. Now the term equations and balancing is related to mass, and there's a little bit of mathematics involved. Again, keep in mind things like the lowest common multiple that we looked at on Monday. Things maybe with expressions when you have pronumerals are things that you need to keep in mind as well to be using in today's topic. Um, so the intention will be to understand that chemical equations must be balanced to satisfy the law of conservation of mass. So with the conservation of mass, I'll explain in a second. Understand how to identify which atoms or molecules need to be balanced in a chemical equation, and then understand how to balance atom molecules in a chemical equation. Okay? So the success criteria after that is you should be able to identify balanced and unbalanced atoms, molecules in a chemical equation, and finally is to balance chemical equations. So let's go back to a few definitions. So it's the conservation of mass. Do any of you know what conservation mean? As a general term. So conservation mean is nothing's changed. It's still the same from before and after. The mass will relate to the amount of material, okay, and usually the unit you use is kilograms or grams, okay. So conservation of mass means mass cannot be created neither destroyed, okay. So in a chemical reaction, the mass of one element at the start of the chemical reaction will equal the mass of the same element at the end of the chemical reaction. So to summarize, the mass at the start of the reaction is equal to the mass at the end of the reaction. So an example of a reaction, and I know it's counterintuitive, but a common chemical reaction is combustion. So when you burn something, let's say you take a piece of paper and you burn it off, what you left after is just carbon or burnt material. If you were to actually measure the mass on a scale, you will find out that the mass of paper you start with will be exactly the mass afterwards, but you will also need to include anything that will come out as well. Not only as a chemical reaction, you will have carbon dioxide and water that will be carbon dioxide that will be emitted, and other materials afterwards. So the total mass will be unchanged. All right. Let's look at some example of chemical equations. First is we look at unbalanced. So the unbalanced means they're not finished, they're incorrect the way they are. So here you have molecules. So here you have Fe2 means you have two ions. If you use your periodic table, you will know that Fe is iron and O is oxygen, but you don't, for today's work, you don't really need to know that. It's good that for you to know in general, but for today's task, you don't really need to know. So I'm just going to remind you that Fe is iron. So you have two iron and three oxygen. That's a molecule. And the C on its own is a carbon. It's an atom, but it's also a molecule because it's on its own. So here what you have a chemical reaction, that's the arrow. So what you have on the left is what you have before the reaction, and when you have the reaction, that's what you have at the end. So when you start with is what we call the reactants. So the chemical are the reactants you start with, and after the reaction, the chemicals you end up with, which can be atoms and or molecules, are called the products. Now, the way we know it's unbalanced is you need to count the atoms that you have on the reactant side as well as on the product side. So on the reactant side, you count, what you need first is list the atoms that you have. So you have iron, oxygen, and carbon, and you list them. And then what you need to do is count them. To do that, you look at the number afterwards. It's a suffix that tells you how many of the previous atom you have. So the 2 here indicates that you have 2 ions. So there's no other ion on the left hand side, so you put 2 here, 3 with oxygen, and carbon has no number, so it means it has 1. You do the same on the product side, so you have 1 iron, 2 oxygen, and 1 carbon. And when you compare the reactant and the product sides, you will notice that you have an imbalance. It means you don't have the same value before and after for oxygen and iron. So that's why it's unbalanced. The same here, you have also another chemical reaction when you have nitrogen gas and hydrogen gas. When you do a reaction, it will combine to is that nitrogen, hydrogen nitrate. I can't remember the name of the chemical here, but it's an NH3. It doesn't really matter with the name for now. What you need to do is list the number of elements, and you can see that the reactant and the product is not equal. You have 1 nitrogen on the product side, and you have 2 nitrogen on the reactant side, so it's unbalanced. Here you have another reaction. This one is a combustion. So what you have is you have a hydrocarbon here combined with oxygen. When you burn it, what you have as an emission, the products will be carbon dioxide and water or steam. It doesn't really matter. You don't need to name the molecules. What you need to do is to count the atoms on the reactant side and the product side, and you can see the left hand side and the right hand side do not match. You don't have the same number. Okay, so that's what we call unbalance. The next step, the next example, is we're going to look at balanced chemical equations, and then later in the next slide I'll show you how to balance those unbalanced chemical equations. So you start with unbalanced. Ideally you want to balance them. So here are 2 other chemical equations. What you need to do, if you could do, is hide the product and reactants and look at the chemical reaction and try to figure it out, the number of atoms for the reactant and the product. There is a main difference with the unbalance, is now you noticed in front of the molecules you will have a number in front. The number in front is the same as when you have a mathematical expression. When you have 3C in mass, it tells you have 3 times C. Now we apply that to chemical pattern. It means we have 3 carbon atoms or molecule on the reactant side, so you can write C equals 3. Here, when you have a 2, it means you multiply by 2 everything that you have on the side. So because you have an O3, you have 3 oxygen atoms for this molecule, you need to double it. So 2 times 3 will give you 6 oxygen. You do the same on the product side, and that's how you get the product and the reactant. And you have 463, and you have 463 on the right hand side. So it is balanced, and that's what you aim for. Through the steps, when we do the work examples, there's a few steps for you to do and repeat for you to achieve the same number of atoms on the left and the right. And because you have the same number of atoms before and after, that's what we call a conservation of mass. The mass before is the same as the mass after. And you have two more examples over here, so you can have a look at it through the PowerPoint. For the ones watching the recording, you can just pause this video and have a look at those reactions and try to figure it out, the atoms. Alright, so this is the steps that you need to do to balance the equations. Step 1, you need to identify the number of atoms for each element molecules on either side of the equation. And what you do is you would list them in a table. Step 2, once you have listed the atoms, you record the number of atoms for each molecule in a table. Okay, so you will see that you will have a left and a right hand side, and it will not be the same. So what you will do is step 3 and 4, you would repeat those steps, and those steps 3 and 4 are new, and I will read them to you, and I will show you how to do those steps in the next example. So step 3 is you choose an element or molecule to start balancing. It doesn't matter which one you pick. I would go from the left to the right, but with experience you can pick a different one. Step 4, you add a coefficient. So it's about, a coefficient is you multiply. Okay, it's not adding. So when you add a coefficient in front of the element, then you can recalculate the number of atoms. So that would be what you would do in step 4. And then you can compare the before and after, or the reactant and the products. And if there's no match, if it's not balanced, then you repeat step 3 and 4 until you until it's fully balanced. Alright, so work example 1. Okay, simpler example. So looking at this reaction, you have N2 plus H2, those are the reactants, and then you have your product NH3. Now below it shows you the number of so step 1 is you list the atoms, so you have N and H. Okay, and step 2, you will count how many you have for on the reactant side and on the product side. Okay, now this is a better way to do it. So what I would do is create a table like this, have a column for the reactant, a column for the product, and here on the left in the first column you just list all the atoms. So you go from the left to the right, you see there's an N, you write N. There's a H, you write H. You keep going, you have N and H, you already written it down, so you're done. And then you do the counting. Okay, now this equation is simple enough. You wouldn't have to do in a table, but having a table like this, it's a better organization when it gets a little bit more complicated. Now for you to do the practice, make sure you have a workbook and probably a Gray lead unless you can use another screen, but it's a bit harder because you need to have this screen in front of you so you can see as well. But if you have a piece of paper and a pen, you can scribble down and do the working out yourself. So have a table. So if you do that yourself, don't worry about the other table with a ruler. Just do quickly hand draw the boundaries, the lines. Now notice this equation is unbalanced. The reason why it's unbalanced is you have 2n on the left hand side, but you only have 1 on the right hand side. Okay. All right. Now identify which elements are unbalanced. Okay, and they're both of them. So if I go back to this one, so I mentioned the n is unbalanced, but it's the same for the h. You have 2 on the left and you have 3 on the right, so both of them are unbalanced. So you need to list the ones that are unbalanced. So you have your n and h, and you need to pick one of them to balance. Now it doesn't matter which one you pick. As I said, I would go from the left to the right, which is n, but in this situation they will pick h. Okay, so h is, you have 2 on the left and 3 on the side. Okay, what do you need to do is, if I put a 2 in front of h, how many h would I end up with is 4, but that wouldn't match the 3. So when you have a h of 2 and 3, do remember how to do your lowest common multiple. So what is the lowest common multiple between 2 and 3? So with the multiples, think about your times tables. So when you have your multiple of 2 is going to be 2, 4, 6, 8, 10. And the multiples of 3 will be 3, 6, 9, 12. Now the common value and the lowest one is going to be 6. No, 6 was correct. Okay, and it's the lowest common multiple of 2 and 3. So to get to 6, we need to multiply this one by 3. And this one, to make the h becomes a 6, we need to multiply by 2. So remember, you need to have a 3 and a 2 here. So how do we balance this? What we need to do is we need to multiply this one by 3 and this one by 2. And now what you need to do is list the product and reactants. So I'm just going to pause my side of it. So what you would do is you do that table, and what you can do is reuse the table that you have drawn. I have a PowerPoint, so I can create a new one, but with yours, what you can do is just cross off the values. So here your N2 gives you 2, and here you recalculate your hydrogen. So you have 3H2, so it means you have 6 hydrogen atoms on the reactant side, and you have the same on the product side. Okay, now is the equation balanced? And yes, it is balanced because the numbers are the same on both sides. Okay, so there's no number you need to add, as it is balanced. Okay, all right, next work example is you have a this equation. So you have iron. What you need to do again, don't use this way of hang on, let me read. All right, so with this equation, what you will need to do is, step one is list all the atoms that you have as reactants and products. So you scan from the left to the right and you list them. So you have your Fe, which is your iron, you have your oxygen, and you have your carbon. You carry on. Is there any other elements that is new? There's none, so you only have 3 elements. And then you need to do a count of how many of each of them you have as reactant and how many of them you have as products. And okay, let me see. How come this? All right. So you have your table. I thought I had a new table here. Hang on, no. Okay, so you have your reactants and your products. You start. Let's say we start with oxygen that we want to balance. How many oxygen? We have 3 on the left and 2 on the right. How do we get to make what value needs to be equal? So you're looking for your lowest common multiple, which is 6. So we need to multiply this one by 2 and this one by 3. Okay. So by doing this, you need to have a 2 on the left and a 3 on the right. Okay. And now you need to recalculate your product, your reactant and products. So for the reactants on the left hand side, what would be different? So you have 3 atoms. You have your iron, which is your Fe, you have your oxygen, which is O, and you have your carbon. So how many atoms do we have now on the reactant side or the left side? So they are the things that you need to figure out, and you do the same on the right hand side. Okay, so because you multiply now by 2, you do a 2 times 2, that gives you 4 iron, and with the oxygen 2 times O3, that's 2 times 3, that gives you 6. You do the same on the right hand side, and now your oxygen are the same. Okay, okay. Now if you notice, we balance the oxygen. Okay, your carbon is still unbalanced, and the same as your iron. Iron is 4 and 1, carbon is 1 and 3. Now you need to pick which one to balance next. So let's say we balance iron. Okay, now question, what number would I place in front of the Fe on the product side? So you have a 2 here, that's the reactant side. What number, what value do I put on the iron on the product side? Sorry, left hand side is reactant, and that's the product side. So what value, what coefficient do I need over here? Now if I put hang on, okay, you're fixing it. So yes, you have 4 on the left. You need to multiply this number by 4. So what we need to do is having a 4 down here. Okay, so we put a 4. Okay, and now we can recalculate your table. Now there's only one value that's going to change. It's going to be this one. Okay, because 4 here only affect your Fe, the others shouldn't change. Okay, so you can update your table. I made a copy, but you can just cross off your 1 and put a 4 next to it. Okay, what's left now is your carbon. You need to balance. Okay, so we're down to carbon. We have a 4 here. So carbon is a 1 here and a 3. So what coefficient, what number needs to be in front of the carbon? So it's going to be a 3, you multiply by 3, you put a 3 next to your C, you update your table, and now both sides are the same. Okay? So now that both sides are the same, your equation is balanced. Now if it wasn't, you would have to go back and pick an element to balance. So either looking at here the left, the reactant on the product side, and just find the new coefficient. And sometimes you might need to have a coefficient on both sides. That's when you use the lowest common multiple. Okay, so that's the end of the PowerPoint.